Hi everyone, we are going to start a new lesson. Name of the lesson is Interpretation of Topographical Maps. We will not be doing the interpretation in this lesson, but we'll have some basics about maps. So the topics to be covered in this lesson are the basics about map, and then the elements of map and types of map. Then we will see one important part of this topographical map. Let's begin. Now, as you know, as all of you know, the shape of the Earth is spherical, can be best represented by a means of globe. So that's the best method to represent globe, whereas it is not sufficient or good enough for studying about Earth. It's difficult to carry. It cannot give much information. Right? There are a lot of limitations of globe. Thus, we go for map. Map is the two-dimensional representation of the Earth or globe, and when it is represented on a sheet, we can have more information, we can have much more benefits, and that is why map is more significant than globe in terms of study about the Earth. So here in this lesson we will be studying about the map, the basic things about map. So map can be simply called as the two-dimensional representation of the Earth, and the art and science of making map is called as cartography, or can also be called as the study and practice of making maps. And one who studies about this, or one who make map, is called as a cartographer. These are all the basic things which I think most of you know. Now we can define map as a representation of Earth's surface or a part of it showing natural or human-made features drawn to scale on a flat surface, or else in simple we can say it is the representation of the surface of the Earth on a plain sheet. Now let's see the elements of map. Again, these are also the basic things. These are the major elements of map. A map should have a title, then scale, direction, grid system, convention sign, and key. Now title means is the title of the map or the name of the map. It indicates the details or the theme shown in the map. Here we have an example. This is the physical map of India. So by looking at the title, we can understand what this map is showing. This is what is called as title. So it's essential for all the maps. Then only we will get an idea about the map without going in detail. Now another important thing is a scale. Scale shows the ratio to which it is drawn. We cannot represent the Earth in the same size. We have to draw to a small scale, or we have to reduce to a short scale. So the method that we use for reducing the original shape size of the Earth to a small sheet of paper is called as scale. We'll study about this in detail. Scale can be represented in three different ways, and nowadays in most of the maps we can see this kind of representation using a line. This is called as graphical representation of a scale. We will study about this in detail in one of the coming lessons. Now another important thing is direction, or the north arrow. Usually the general maps are oriented towards north side, or the meaning is that when we take a map, the top of the map generally points towards north direction. So it is represented using a small arrow. It is called as north arrow. It can come in different size and shapes and designs, right? So that's direction. And another important element is grid. Grid is a system of lines, or a network of lines made up of latitudes and longitudes. Here also you can see we have the latitudes and longitudes here. Longitudes are valued like 70 degree east, then that is 75 degrees, 80, 85, 90, 95, and we have latitudes, so 20, 25, 30. So this system of latitudes and longitudes on a large map is called as grid, or the Earth's grid. And this is used for locating a place. Say for example, if we take this blue dot here, we can say the blue dot is located at 35 degree north latitude and 85 degree east, and that means this is the unique value of that one particular location, and that is what is called as coordinate of that place. Again, this is the basic things. Similarly, if you take this orange dot or this red dot, each and every dot has its own location. That means with the help of this grid system we can locate any place on Earth. That is what is called as the grid. Now the next important thing is conventional signs and symbols. These are some signs and symbols which are used generally throughout the world for a long period of time, and all these signs has some unique meaning. Say for example, here in this map you can see blue color lines. This represents rivers. Wherever you go, whichever map you take, The blue color is used for showing water bodies. Similarly, there are hundreds of conventional signs and symbols, but here in this map we are not using much because it is not needed. Or basically, if you see, you can see this green color area. Wherever it is green, it shows plain area where the height is less than 100 meters. Generally, green color is used for showing plain areas in a physical map. This is also a conventional sign. We'll study about conventional sign in detail again in the coming portions. Now, another important thing is key. It can also be called as legend or index. Key or the legend shows the signs and symbols which are used in a map. Here we have one set of keys here. It shows three different symbols. This violet line shows international boundary. You can see the boundary between Nepal and India, Nepal and China, Bhutan and China, Bangladesh, India. All these boundaries are shown using violet. So the meaning of this violet is given here in a key. Or river again. The sign used for showing river is also shown this one, or the sign used for showing mountains. Right. So this is what is called as key or a legend. So these are the 6 basic elements of a map: title, scale, direction, grid system, conventional signs and symbols, and now next topic is the types of map. We can classify maps on 2 bases. First one is on the base of purpose and content. Second, on the base of size. Based on the purpose and content, the map is classified into 3 categories: the physical map, political map, and thematic map. And based on the size, map can be classified into small scale map and large scale map. Now let's see the first one, physical map. Physical map is a map which provides details about the natural features or the physical features. Here we have an example. This is the physical map of Karnataka. It shows the elevation. Say for example, here we have the key. In key, it is showing different colors, and different colors indicates different elevation. The most common thing that we see here is brownish color. That means these areas are located at a height between 600 and 900 meters. Then this darker brown means the areas which are located between 900 and 1350. So in this way, this map is used for showing physical features. You can see the rivers also, blue color things, right? So a map which shows the natural things or the physical features are called as a physical map. Now, another type of map under this category is a political map. Political map is a map which shows the political divisions or the administrative units and boundaries. Again, this map is not showing any physical features, but it is just showing the administrative units. We have all the districts of Karnataka here, and we can see the boundaries of all of them. So this kind of a map is called as political map. And the third one is called as thematic map. A map which is used for representing any one particular theme. Say for example, to show vegetation, that means different types of forest in an area, or temperature, or population density, or whatever it can be. So it shows information about one particular theme over a large area, or a small area, or a country, or district. Here we have an example. This shows the COVID-19 active cases as of 27 April 2020 in Karnataka. And here again, different colors are used as different signs. Green color indicates no active case. That means all these districts don't have any active COVID case as of 27. Whereas the red indicates that these are the districts with more than 15 active cases. Right. So in this way, different themes can be represented in a map with the help of different colors, signs, symbols, and these kind of maps are called as thematic maps. Now we have the next type of classification, that is based on the size. Based on the size, maps can be classified into small scale map and large scale map. And small scale map is a map which represents a large area, like a world map, but usually it gives way less information. We have mainly 2 examples. One is called as the wall maps, and second one is the atlas map. You are all familiar with both. Wall maps are usually used to hang in the wall, like in schools or in offices and all, where it shows a large area, but the information that we are getting from wall maps are comparatively very less. We may get the name of all the countries, maybe the capitals and some important cities and few important rivers and mountains, but you don't get much information other than these basic things. Similarly, in atlas map also, map shows a large area. This is the entire European continent. We may get the name of all the important cities, countries, capitals, but we will not get anything else. So this kind of a map which shows a large area is called as a small scale map. Now the second type of map is called as a large scale map. Large scale map represents a small area, comparatively very small area. Since it is representing a small area, it can give more information, much more information about that one particular area. Again, we have examples. We have something called cadastral maps. All these maps are together called as cadastral maps. The revenue maps which are available in the panchayats or in the block panchayat map and a city plan are all examples of cadastral map. Now, another important example for large scale map is topographical maps. And in this year, we will be studying about topographical maps in detail. Now, what is a topographic map? A topographic map also can be called as topographical maps. Then it can also be called as the Ordnance Survey Sheet of India or the Survey Map of India or the Topo Sheet. There are so many names, but all are same. And these are maps that are detailed, accurate graphic representation of features appear on Earth's surface. Or a map, a large-scale map, which shows both physical features as well as human-made features, is called as a topographic map. Right. Now, the main features which a topographic map shows are the cultural features or the human-made features as well as the physical features. So these are all the important human-made features which is shown in a topographic map. It includes roads, buildings, urban development, railways, airports, name of places, so and so and so. And physical features like hydrography, anything related to water, lakes, rivers, streams, all those things are shown along with all these human-made features. Then relief features are also shown in the same map, and wooded areas like forest areas are also shown in the same map. So this is one unique map which shows a huge or a large number of details in a single map. Right? It shows both physical features, cultural features. Right? So in the previous classification we have seen thematic map, political map, cultural map, and also they cannot show all this kind of details in a single map, whereas topographic sheet can show both cultural as features as well as physical features. Here I have given different colors to all these things. Say for example cultural features or the human-made features. So in a topographical map, human-made features are represented using a red color. Anything related to water or all the water bodies are shown using blue color. Relief features like valleys, contours, all these things are shown again using brown color. And vegetation or the forested areas are shown using green color in a topographic map. Now here we have an example of a topographic map. This is a large topographic map, and yeah, you can see this shows parts of Kerala and Tamil Nadu. Actually it is showing only parts of these three districts: Trivandrum districts, Kanyakumari districts, and Tirunelveli. This is in the extreme south. It shows a part of these three districts. Right? This is why it is called as large scale map. It shows a very small area, right? And the survey was conducted in 1967-68. So this map was prepared after doing a very long survey. Right? We'll study about all those things in detail. And if you see the other important features, it shows a lot of things. It shows the north arrow. Right. On the other hand, it has a title or a name. Which is used, which is represented using a number 58H part 2. So this number is unique. There is only one map which has got this one particular number. So by seeing this number, we can understand which part of the country it is showing. And if you go into the details of the map, you can see some brown lines here. These lines, somewhere it is very close. These lines are called as contour lines. They represents elevation, height, and these black lines, these are actually streams. It is black in color because they are seasonal, they don't have water throughout the year, whereas here these are blue. That means this area is perennial, where the water is available throughout the year. And these isolated values like this shows spot height. Here we have a dot and the value 854. That means height of this particular place is 854 meters above the sea level. Then it's written dense mixed jungle. That means this area is covered with dense mixed type of jungle. If we go to this area, we have again overall we have maybe two types of colors. Here we have a greenish color and this is a yellowish version. So green color represents forested area, yellow represents agriculture area. Right, in the same map we can show forest, agriculture along with height. Contours are used for showing height, and here you can see a lot of red color things. So let me zoom into this one. So here we have double line, red double lines. These are metal roads. Metal roads are shown using these kind of double red lines. Then you have a lot of like small squares of squares red in color. This indicates huts, permanent huts, or permanent houses. Then we have a symbol here. Right, this symbol shows a temple. Or if you go here, you can see it is written PO. That means post office. This is dispensary. Arena. This is the place of that name. Police outpost. Or again, there is another spot height. So the height of this place is 140. That means this is a small what is it, hill, right? Then we have blue color. Blue color again represents a river. Name of the river is also written. This is Karamana river, one of the river in Trivandrum districts, Kerala. Then here we have an area with whichever is fine. So here we have an area, right, where trees are arranged in a straight line, and there is a rubber plantation. Or here again a rubber plantation, right? So this is a map that can show both physical features as well as cultural features, and there are a number of signs used here, right? All signs have its own meaning. And then here you can see another sign, right? And there is a value 5R. Then there is another value 3R. There's a blue circle here, right? Then there is a triangle with a value. There is something written RF. So each and everything shown in this are called as a conventional sign or a conventional symbol, and it has got some meaning. And all these details are given in the key here at the bottom, right? So double lines, red in color, shows metal roads. Right? If the width is little less, that indicates less important than the other one. Then unmetal roads are shown using broken lines. Then water bodies are shown using blue color. This represents a tank. Then 2R that shows the relative height or the depth. Then this kind of lines, black line with small cross lines, again shows railway lines. Again, it's of different importance. RS, railway station. And the brown color line which I shown you in the beginning, that shows the contour lines. We'll study all these things in detail. Then we have the scale of the map. 1 centimeter is to 50,000 meters. That means 500 meter to 1 centimeter, which means 1 centimeter on the map is equal to 500 meter on the ground. Then the distance between contours are given there. It's called as contour interval. Or if you go again in detail, we'll get an idea under whose guidance the map was prepared and in which year it was published. So this one particular topo sheet was published under the direction of the Brigadier J.S. Painter, MIS, Surveyor of India in the year 1969. On the top we saw that then the survey was conducted in 1967-68 and it was published in 1969. Now we have some more conventional signs and symbols here on the other side. So it shows a meaning of almost all the signs and symbols used here. Now this is actually the location map. So these are the main two districts which are shown in the map. This part shows Tirunelveli districts of Tamil Nadu, and this small part shows the parts of Kanyakumari districts in Tamil Nadu, and the major area is coming under Trivandrum districts. So altogether it shows a comparatively very small area. So these kind of maps are called as topographical maps or topo sheets. You also have the same thing with you. You have to turn to the last page of your textbook. You have some 6 to 7 topo sheets attached, right? So that we'll see later. There is another topo sheet, right? Same thing, right? But here we have something extra. These lines, these red lines which were not there in the previous one. Right? Here those lines are missing. Here we have this. So I'll tell you what it and why is it important, and we'll be studying only about these lines and its importance today. Now, I told you each and every map has got one unique number. So this number helps us in identifying the location. Now, what is the importance of this, or what is this thing? This is the reference number, or we can say this is the grid reference. To make it clear, we have to understand how this done. The entire area, India and its adjacent countries are surveyed. Survey was started during the time of Britishers, and the entire country was divided into a number of such columns. And here these boundaries are actually latitudes and longitudes. Right, they are running at an interval of 4 degrees. This is 16 degree. Next one is 20 degree. Next is 24, 28, 32, and longitudes also 60, 64. Sorry, this one is, I think, yeah, whatever it is in, okay, 4 degree difference, right? So this is 84, then 84 plus 4, that is 88, then 92, correct. So this is 76, 72, then this is 68, then okay. So latitudes and longitudes are drawn at an interval of 4 degrees, and these are all numbered, and the entire India and surrounding, not only the India surroundings, almost the entire world is surveyed like this, and number is given to each and every grids. And in case of India, the numbering starts from 37, then 38, and it ends at 93. So if I say grid topo sheet number 55, that means this entire area. Nowhere in the world we have a topo sheet with same number, so we don't have any confusion. Now it shows a large area actually, 4 degrees difference. 1 degree is approximately 111 kilometer on the ground, so 4 degree means almost 400 plus kilometers. So these grids are further divided. If we say select only the first one, 55, right, this one is 55, sorry, topo sheet number 55, that is further divided into 16 units, right? 4 from one end to other end, it is 4 degree, so it is divided into 4 equal parts, horizontally and vertically. That means each of these are 1 degree apart. If this is 16 degree latitude, next will be 17, next will be 18, then 19, 20. Similarly vertically also, if this is 20, next one will be 21, next will be 22, 23. So each and every grid has one unique number again. This number using alphabets A, B, C, D, E, F, G. So if we select any one of these, suppose if we select this one, then that one particular topo sheet is called as 55P. So when we say 55P, it is here in this area, right? So in this way, each and every part or each and every topo sheet has got a unique number, and it will help us in identifying that location. It is further divided into again smaller units in 2 different ways. In one type of classification, it is directly divided into 4 parts, where it is divided into northwest, northeast, southeast, and southwest. Or in another type of classification, it is further divided into 16, and again given the number numericals 1, 2, 3, like up to 16. Again, if you take one particular grid, then that is called as 55P. Then if you select 7, then that is 7. So this type of classification done is called as the national grid reference. So this grid reference is used for given to all the topo sheets, and by seeing this grid reference we can identify which part of the country it is shown, right? So this kind of a map, or a map which has number like 55P/7, is drawn at a scale of 1:50,000. That you will understand when we study about scale. Now, the survey was conducted under the Survey of India about 100 years ago by the British surveyors. Later on, they prepared the maps in their system. It's called as the British system of numbers. That means the unit was inch, then miles, so and so and so. So later, after the independence, all these units converted into metric system, the system which we use here, like centimeters, meters, and kilometers. Right. So the entire country, India and its surroundings were divided together into a number of units. They had a total number of 137 such divisions. Right. But most of these does not, some of this does not belongs to India, like this part that is exclusively for China. So we don't take all this into consideration. We need only those which covers our area. And in this year, that is in 10th standard, we will be studying about two of these type of topo sheets. One is 45 d bar 7, other one is 45 d bar 10. Both shows altogether a very small area, and it's actually part of Rajasthan and Gujarat state. Now, in this video, we will be studying about only this one topic. Whatever we saw so far up to this are just for reference. You don't need to by heart any of these things. Just need to understand. Right? All these topics which we covered so far is just for understanding. Right? These are the basic things. What you need to know is all these basic things. What is map and its elements, types, classification. Right? Don't need to by heart any of these things. Just keep in mind the basic things. Whatever you need is the things that we are going to discuss from now onwards. Right. Now, the most important thing is this one. Today we'll discuss only about grid. Grid, as we know, it's a set of lines used to find locations on a map. And on a large map, a map which shows the entire world or a country, we use the grid formed by latitudes and longitudes to represent a location, like this. So here we have a set of latitudes and longitudes. It can easily be used for locating any place on this, because it shows a large area. We are not going too deeply. Say for example, if we take this point A, we can say A is located at 30° north and 60° east, 30° north latitude and 60° east. Or K, if we take K, it is 75° north latitude and 60° east. Or if we take J, it is at 75° north latitude and 0° longitude. In this way, we can represent any place. But there's a problem. The problem is, if we go in detail, like if you go into a smaller area, we may not be able to use latitudes and longitudes. Right. Whatever. Now, grid reference, another important term is grid reference. So grid reference is actually the coordinate of this one particular point. If you take this A, the coordinate of A is 30° north latitude and 60° east. So that one coordinate of this one particular point is called as its reference. So by seeing the reference, or just by looking at the reference, we'll be able to understand in which part of the world or in which part of the country a particular place is located. Or if we take this one, it is 45° north and 75° west. So by just seeing the value, okay, it's in the western hemisphere and it's in the northern hemisphere, we can simply get an idea where it is located. Then with the help of a map, we can precisely locate places. So for that we use grid, and the coordinate value of each and every point on earth is called as a grid reference. Grid reference is a map reference indicating a location in terms of a series of vertical and horizontal grid lines identified by numbers. Now here, when it comes to a topographical map, we have latitudes and longitudes. These black lines are longitudes, vertical lines are latitudes. But the problem is, we have already reached the lowest possible. This one particular line is actually 76° 30 minutes north latitude, and this one is 76° 32 minutes 30 seconds north latitude. This is 76° 35° north latitude longitude. That means if we want to locate any place which is located inside this area, we cannot use latitudes and longitude, because we cannot divide this again. So it's same with latitude also. Here this one is 16° 27 minutes 30 seconds north. This is 16° 30 minutes north. Now we cannot divide this using the degree minute system. So in this kind of a map, in topographical map, we need additional lines for representing place. For that we use these vertical and horizontal lines. All these vertical lines and horizontal lines are drawn at an interval of 2 centimeters. On all the topo sheets, it is drawn at an interval of 2 centimeters. That means 1 kilometer on the ground. And each and every line has got a unique number. And the numbers are increasing from left side to right side as well as from bottom to top. These vertical lines are called as eastings. These vertical lines are called as eastings, and the horizontal lines are called as northings. So the grid which is formed by eastings and northings together is used for representing locations or places in a topo sheet. The reason is very simple, because in a topo sheet we are showing very small areas, right, which cannot be located using latitudes or longitudes, because they are even smaller than the distance between two latitudes and longitudes. So we have created additional lines or a grid system that is called as the grid system, and these are made up of horizontal and vertical lines called as eastings and northings. Eastings are the vertical lines, northings are the horizontal lines. Together they form a grid, and the numbering starts from bottom left side. So number of northing starts from the bottom and it increases towards the top. So this is 52, this is 53 northing, this is 54 northing, this is 55 northing, this is 56 northing, and this is 57 northing, and so on. And the values of easting start from left side and increases towards the right side. So this is 25 degree northing eastings, this is 26 degree easting, this is 27 degree, this is 28 degree, 29 degree, 30 no degrees here, just numbers only, 25, 30, 26, 27, 28, 29. So this way the value of the eastings increase from left to right and the northing increase from bottom to top. And there are two types of grid references. One is called as 4-figure grid reference, another one is called as 6-figure grid reference. Both are used for locating places, but they have slightly different purposes or functions. Now let's see the first one, 4-figure grid reference. As the name suggests, 4-figure grid reference contains 4 numbers in total, and it is used for finding out location that lies within one particular square. And when we write the grid reference, 4-figure grid reference, we write 4 values continuously like this. Say for example 1844. Here the first 2 values indicates the eastings, which indicates the values of eastings, and then the second 2 values indicates the northings. Right. Say for example we have this one particular grid or this particular question mark. So what is the 4-figure grid reference of this one particular grid? Or imagine we have some feature here, there is a pond or a lake. So we want to locate this place, or you want to tell this to someone that there's a pond located in this map, and if you want to tell the exact location, we have different methods. You can say it is in the middle, it is in the left side, it is in the top side, but the best method will be giving a value or a number so that the other person can easily locate that place. So for that we can use 4-figure grid reference. So for this one particular grid, what is the 4-figure grid reference, or how can we find it out? So this is the grid, and to find out the 4-figure grid reference of this particular grid, what we need to do is we need to take the northings and the eastings located. In case of eastings, we have to take the easting which is located on the left side. Always the easting located on the left side is taken, and northing taken at the bottom is taken. Right? We have to take eastings located on the left side and the northing located at the bottom. Then the next step is writing these values continuously without any gap. First we should write the value of the eastings. Keep in mind always we should write the value of eastings, then we should write the value of the northings. That is 1844. Right? That means 1844 is the value of this one particular grid. Or if you take another example, this one example, so So this would be, we have to take this line first, that is 19, then this is 46. Or if we take this one, this is 16 and this is 42. So every time we write eastings first, then northings. It's very simple. E comes before N in the alphabetic order. Simple as it is. Now, in this way, we can find out 4-figure grid reference. Or we'll take one example from a topo sheet. So here we have a lot of features. Now we'll go for this one feature. It's called as a stony waste. Stony waste is nothing but an area which has a lot of broken pieces of rocks. That again we study later. Now the question is, what is the grid reference of this one particular stony waste? This area is actually extending beyond one particular grid. It is extending to this one as well as this one. But always we have to take the eastings and northings which is on the left and the bottom, right? So it is extending from here to here, and we should choose the eastings immediately on the left side and the northing directly below. So this value is 84 and this value is 98. So the 4-figure reference of the stony waste is 84, 98, right? So in this way we can find out 4-figure grid reference, and we can locate any place, right? And this is usually used for locating a large areas. A large area means an area which actually occupies almost one entire grid. I told you that the distance between two eastings and two northings are 2 centimeters, which is equal to 1 kilometer. That means one grid represents 1 kilometer square area. So we usually use 4-figure grid reference for representing large features like this kind of stony waste or a lake, right? All those kind of features. Now the next 6-figure grid reference. Just like the name saying, it contains 6 numbers. In the previous one we have only 4 numbers. First 2 are eastings and next 2 are northings. Here we have 6 figures, and this is used for pinpointing locations to find out the exact location. We have a lot of features like a well, tree, hut, temples, which are shown using a very minute dots in a map, right? Suppose if we have a grid system like this and we have a yellow dot here, so how can we represent, so what is the grid reference of this one particular yellow dot? What is the exact location of yellow? Is 4-figure enough? 1743 is the 4-figure reference. If you are giving this reference to someone else and saying that this yellow dot is located in 1743, that means it can be, or this yellow dot can be anywhere inside this one particular grid. So it is not sufficient for point entities like a dot. So in order to locate the exact location of point features, we go for 6-figure grid reference. 4-figure grid reference is used for showing a large area, whereas 6-figure is used for representing or locating a small entity like this. Now how to do this? Our method is same. First we have to find out the 4-figure grid reference. Here it is 17 and 43, and we will write like this with a space in between, right? So first is 17, again we write this easting first, then we leave a space for one more number, then northings 43, then leave a number. Now the next is, here this is 2 centimeters, that means 20 millimeter. Next task is dividing this into 10 equal parts. 20 millimeters divided into 10 equal parts means 1 unit is equal to 2 millimeters. You don't need to necessarily like draw lines like this. You can use simple calculation also, but to understand this is the best method. You divide into 10 equal parts and take the eastings which is located immediately on the left side, right? So divide into 10 equal parts, use your scale when you get this question in a topographic map, then take the eastings which is located immediately on the left side, right? And here these are numbered as 1, 2, 3, 4 up to 9, right? Next one is 10, that means the next eastings, right? So here we don't use 0, we just write in single digits 1, 2, 3 up to 9. And here for this one particular yellow dot, the figure easting is 6. So after 17 we have to write 6. We don't use 0, only 6. Now similarly for northings also we have to divide into 10 equal parts, and we have to take the line which is directly below the given location, that is 7. Then we will write the value. So there are 6 values here, right? 17, 6, all 3 are eastings. It shows all 3 are eastings and these all 3 are northings. 43, and within 43 7 the northing. But in this way 6-figure grid reference is used for locating a point feature. We have again one example from a topo sheet. So here in this topo sheet you can see the northings 24, 23, 60, 62, and previous one is 60. And there is a small feature, it is called as a prominently surveyed tree. Now what is the 6-figure grid reference of this particular tree, a prominently surveyed tree, or what is the 6-figure grid reference of this feature? So to find out this, first we have to write the 4-figure reference. This is 61. Numbering starts from left to right in case of eastings. That means this is 61, next one is 62, so previous one is 60. So this is 60. So first we will write 60, then we will leave a space. Then the northings, the one which is at the bottom, that is 23, then we leave a space. Now next is dividing this. Right, you don't need to necessarily divide it. What you can do is you use a scale and take the measurement in millimeters. Right, if it is some 18 millimeters, say for example, you divide it by 2, that is 9, then this would be 9. Right, so here it will come somewhere around 8, and we will write the value of eastings. Next is again same for northings. Right, you take the distance from the northing to this one particular feature. Whatever you get in millimeters, you divide it with 2. Right, so that will be the value. Here in this case it is 4. So the 6-figure grid reference is 608234. Again, first 3 values indicates eastings 608. That means within 60, 8th eastings, and within 23, 4th northing. Right. So in this way we can pinpoint locations using 6-figure grid reference in a topographic map.